Sorry. Sorry. I'm testing the microphone. Sorry. I'm testing the microphone. Okay, we're ready. I'm testing the microphone. We're ready. Sorry. Okay, we're ready. I'm testing the microphone. We're ready. Okay, we're ready. I'm testing the microphone. We're ready. Sorry. Okay, so we have this question right here, right? We have this question right here. So we're gonna start with this question right here. Let's get started. Okay, cool. So we have a question here, right? But I want to break down for you so well what is a parabola, how to draw parabola, quadratic, coefficients, and all of that. Okay, so I'm going to take one question and break down in other aspects so you have the clarity and understand how to calculate everything. Okay, so I'm going to take the first question, which is going to be, let me take the second one first. Let me start with the second equation first. So I'm going to start with this question here. So first and foremost, what is the coefficient? Okay, before we go to coefficient, because somebody may ask, how do you know some equation is quadratic? A quadratic equation is always in this form. Let's say somebody say a equal to ax plus b, x plus c. So this is quadratic. If it's in this form, means any number must have an x squared. Other one should not have a x squared, just have an x. That's quadratic. For example, means a can be any number, b can be any number, c can be any number. And the c represent Y-intercept. Okay? These are rules. So you have to memorize the formula. Mathematics has a formula, so you have to memorize the formula. Okay? What does that mean? For example, if somebody say y equal to -3c, instead of a, they say -3 and then x squared, and then b, let's say, in the position of b, let's say 3, and then we have x. In the position of c, let's say -8. Or here, let's say -8, and the last one, let's just assume it's -7. So this equation here is quadratic. Why? Because it has a x square, and here there's no square, but it's the same thing, which is x, but it does not have a square. Then you're gonna say this equation is quadratic because it's in the standard form of quadratic. So let's say here it was 3 here. Let's just assume it was 3 power 3. Then we know this is not quadratic. So I'm gonna explain to you in the future what type of equation is there. So any quadratic must have an x square here, and here must have a y. Then you say, yes, that's quadratic. So the first equation here, this is quadratic because it has an x square and there's an x here. And the number before x square here, even though they did not write, then you assume is 1, because whenever you have anything you have and there's no letter, means it's 1. For example, you might say, I don't have to say 1 person. I can say a person means it's 1. That's why there's no number here, but I can say, okay, before x squared there's a 1. So if you can compare with the standard equation, whereby you can, okay, we say, let me write it clear. If you can look carefully in the standard equation here, right? Anything before x squared is a. So the value of a here equal to 2. Anything before x is b always. So the value of b equal to -6. And the value of c is going to be this one right here. That's how you know a, b, c. So anything with x squared, that's an a. And anything with x before, that's a b. So what is the value of a? The value of a equal to half here. What the value of b? B is the number before x. So the value of b equal to -9/2, and the value of c is 7/1/8. And a, b, c. Now we know how to get a, b, c. Now let's go to the actual question, because this has nothing to do with the equation. But at face, you need to know the standard equation. But at some time, look, they're gonna mix up like this, and then you're gonna be like, oh, which quadratic equation is this? For example, somebody give you, let's say y equal to d square negative 4, and then minus d. No, let's just say, excuse me, let's just say, for example, 5. Let's say y. Oh, I'm sorry. Let's say y equal to 5 minus 4d, and then plus 2d. So in this quadratic equation, oh yes, it's quadratic equation. You know why? Because here we have a something square and there's something with not square. Means d square and d is still quadratic. They kind of mix them up just to confuse you. So I'm going to say, well, I know my value of a. What the value of a? A is the letter before d square. So, I can simply rearrange and say, okay, I can say this equal to, I always have to start with number with a d square, or group with a d square. It's going to be 4d square, and then I go to the group which has only 1d, so this plus 2d, and then I'm going to go for the last one, which is 5, but there's no plus here. You assume it's 5 plus. The sign always is before the number, so this can be plus 5. So you have rearranged that equation in a standard form of quadratic. So what the value of a? The value of a equal to negative 4, the value of b equal to 2, and the value of c equal to 5. So quadratic is not only x's, not all the time it's going to be x's. As long as the letter is the same with the square and the letter with no square, it must be the same letter, then it's quadratic. So if you can look carefully here, we can come back to the question. We're going to say, well, this is quadratic, yes, because this is quadratic because there's an x squared and there's an x. And the number before x squared, this could be our a. So our a equal to a half. And our b is going to be that number before x, which is going to be negative 9 over 2. And our c equal to 7, 1 over 8. So now we know how to get a, b, c in any quadratic. Okay? And any quadratic, the highest degree. Okay, let me explain to you something called degree. What does degree mean? The reason I'm explaining this because sometimes they ask you in different ways. So you need to understand what does that mean, okay? You need to understand everything. Okay, so there's something called degree. Degree is the highest power. So what is the degree of this equation? The highest degree. The highest degree is the highest power. So the degree of this, the first equation is 2. What is the highest degree or degree of the second equation? The degree or the highest degree of the second equation is 2. Also, because you look at the highest power. What is the highest degree or the degree of the last question? Is 2 also, because if you look at all those variables right there, the highest one is 2. So that's how you know the degree. Okay? Now, somebody may ask you here, right? What is the degree of x here? The degree of x means the power. So there's no power here. You assume there's a 1 if there's no power. So the degree of x is 1. So you need to know what is the degree meaning. Now let's go to the coefficient now. Coefficient is the number before whatever dimension. For example, somebody may say, okay, what is the coefficient of 6? The coefficient of, my apologies, I'm sorry. What is the coefficient of x? Coefficient is the number before whatever they ask you. So the coefficient of x equal to negative 6. What is the coefficient of x squared? The coefficient of x squared is the number before x squared. So the coefficient of x squared equal to a half. Okay? What is the coefficient of x squared for the second equation? The coefficient of x squared in the second equation is going to be this number. There's no number misses 1. So the coefficient of x squared is going to be 1 here. What is the coefficient of x? The coefficient of x is number before x, which is going to be that one right there. So it's going to be negative 6. So they can ask you either way, okay? But now somebody may ask me, hey, Mtwana what, man? What about the first question right there? Why it only have 2 numbers? Let me explain to you. So we're going to have to write in a standard form of quadratic. I'm going to say this, let me say x squared. There is no x here, so I can introduce by say 0x. Because 0 is like nothing, but I introduce so it can look like a real standard equation of quadratic. And then I'll say 3 1/2. Okay, minus 3 1/2. So then I have rewritten my equation in standard form of quadratic. Then I'm going to say, what is my value of a? A equal to 1. And b equal to 0. And my c equal to negative 3 1/2. So now we know how to determine the degree of x, coefficient, and how to know if the equation is quadratic or not. Now, so it's obvious if you look at these 3 equations, then you know, okay, well, all the 3 equations are quadratic because all of them they have an x squared, and then they have an x's, and then the number means a, b, and c. All of them they do have. Now let's solve them now. So we wanna know how to solve this equation, find the value of x, turning point, where's intercept, what does that mean? Now let's go to the graph. Okay, so we're gonna say, okay, first and foremost, let's just assume you have a, let's say this is our okay, parabola. Okay, these are quadratic. These equations, we call them quadratic, but the graph that you're gonna draw, you call it parabola. The graph that are drawn from those equations, you call them parabola. Okay, the graph are called parabola, but the equation are quadratic. So we have to use this equation to draw the parabolic curve, parabolic equation. I mean parabolic graph or sketch or curve, however you can call it. Okay, now let's get to the business. So I'm going to show you using the formula and using the calculator. Let's start with the formula. So I'm going to, let me start with the second equation. So I'm going to copy the second equation, which is x squared minus 6x plus 10. So let me go to the next page. X squared plus 6x plus 10. So we want to, okay, before we go to that one, any quadratic is always going to concave either upward, and if it's not going to concave out, you see, no, I'm sorry. I was meant to say it concave downward. You see, it kind of open at the downward. So this is concavity of downward. And you know when it's concave down, before even you solve, if you can look at the value of a here, we know a is the value here at the beginning here. So we know it's plus 1, even though it's not written, but we know it's 1. It's like a plus 1. Okay, y equal to like that, right? So there's no sign here, means there's a 1, and we know it's plus 1. Plus 1, because it's just a 1. 1 is plus. So whenever the value of a, when it's greater than 0, then you know before you draw your graph, you know it has to concave down. For now, we don't know where it's going to cut, but we know it's going to concave what? Upward. It's going to open upward. Why? Because the value of a is greater than 0. However, if the value of a is less than 0, it does not matter which number. For example, somebody say, okay, -4, any number. Then this, we know, so, okay, the value of a is going to, since it's less than 0, then by any means, this graph is going to concave downwards. So that before even you solve, you have to know that. So if let's say you solve your question, they realize like, okay, well, it was -4, but then my graph was like that. Then you know you're wrong. You're wrong. Okay. If it's negative, it's going to concave downward. If it's positive, it's going to concave or it's going to open upward. Now, we want to go and solve now. But before we solve the last thing quick, we say, look, if this is a graph quadratic, right? Okay, rough. Okay, let's somebody give it like this. So if you have any parabolic, there's 3 or 4 things that you need to know. These, okay, this x-axis and this is y-axis. So this graph is going to cut at 3 points. It's going to cut at x-intercept. When you say x-intercept, means where the graph is going to cut at x. And then another x-intercept. And then apart from that, also, you see this graph is going to cut at y. Means this is y-intercept. So we have the x-intercept. And in the same graph also, it might come and cut at y-intercept. There is a higher possibility. So what we need to do is find those 3 things. Means x-intercept, meaning where it's going to cut at x-axis, and a y-intercept, where it's going to cut at y. But not all the time it's going to cut. Now I'm going to explain to you now how you're going to know, how you're going to determine when it's going to cut, when it's not going to cut. Okay, let's get to the business right now. Another things, if you have a graph, I'm just giving this a sketch graph. I mean a rough sketch. So this graph, you know, is going to cut at y-axis. Okay, let's do it like this. This will make more sense. Sorry. Let's just make like this. Let's say this x and this y. So if you have a graph like this, then we know this graph is going to cut at x-intercept because this x-axis, x-intercept, and then it's going to cut at y-axis, which you're going to call it y-intercept. There is another point which is very, very important, where the graph turns. So only 4 things we need to get: x-intercept, and then y-intercept, and the last thing is turning point. So if you can find those 4 things, then you're going to be able to solve the question. Now, let's go and solve that question right there. So we need to get x-intercept, y-intercept, and all of that. That it is. So we know before, my fault. Let me go to this question. The question say, the second question say, x squared minus 6x plus 10. X squared minus 6x plus 10. X squared minus 6x plus 10. Okay, now, so we say we're going to find what? 4 things. Let's start with the X-Intercept. So if you want to get X-Intercept, there's a formula that we have to use. That formula, the easiest way, you just say, okay, what the value of A? A, we know is that one, A equal to 1, and B, this number here, before X, -6, and our C equal to positive 10. Positive 10. So we got the formula here. The formula of, so I'm going to show you the formula, and then I'll show you the shortcut way how to use a calculator. So the formula say X. If you want to get X-Intercept, you have to memorize. This is a formula right here. Memorize -b plus or minus square root of b minus 4ac over 2. You memorize that one in a minute. You don't have to use a formula sheet. You have to memorize. So I'm going to say, well, formula say -b plus or minus square root of b square minus 4ac over 2a. So then I'm going to say, well, plug in the calculator, negative, in a letter, put bracket. What the value of b? B equal to -6, because b is the number before x, -6. Plus or minus, square root, b square. B square means take -6, bracket, square. Always put bracket, minus 4 times. Whenever there's a letter, you see me, I put bracket whenever there's a letter. What the value of a? Value of a equal to 1, and then bracket again. What the value of c? My value of c is this one, which equal to 10. 10. And then you have a square root, because you square root, and then you have a square root. And then we over 2 times a, 2. Where there's a letter, I'm going to write my number. What the value of a? A equal to 1. So go straight to the calculator and plug those values quick. Okay. So I'm going to come in a calculator. So, well, let me plug my value. Let me bring my calculator so you're going to be able to see. Okay. Plug in a calculator. So I'm going to say, okay, fraction, because you have it ups and down. And they say negative. In the bracket. Oh, I'm sorry. Negative in the bracket. B. What if b equal to -6? You plug -6 in the bracket. Oh, I'm sorry. -6. B equal to -6. -6. So you follow the formula. Okay, plus or minus. So you cannot plug plus or minus. So start with the 1. So say plus face. Okay, start with the plus face. And after plus, we have a square root. And then I'll simply go to the square root. And then I'll go bracket b. What the value of b? B equal to -6. Come here, say -6. But b is a square, so you come there, you say you square, and then minus 4 times a. What the value of a? The value of a equal to 1. The value of a equal to 1 in the bracket. In the bracket again, c. What the value of c? C equal to 10. So you come here, you plug your 10, and then you close your bracket. And then come right here, 2 times a equal to 1. So then after, just press equal. When you press, oh, say error there. Made a mistake here, sorry. Let's see, did I plug correct? Well, I think maybe I forgot the bracket or something. Or sometime it wants you to put multiplication here in between. Okay, let's put multiplication here. Let's see. Oh, no, it's not. What did I make mistake here? Let me see. Oh, I see. So for that being said, meaning there is no value of x. No problem. There is nothing wrong with this question. Very interesting question. Let me go back to the question, tell you why it did not cut. So I should have taken another question, but hey, this is very interesting. So meaning we don't have X-intercept. So there's a chance this graph is not going to cut at X-intercept because we plug our value correct, but it's not giving X-intercept. So the chance is it's not going to cut at X. So there's nothing wrong with what I did. So I'm going to say, well, I'm going to say now, no X-intercept because we plug in the calculator, but we need to say error. So meaning no X-intercept. No, it's funny because the first question, it didn't give us X-intercept. So this graph is not going to cut at X. Let's find Y-intercept. Y-intercept is this number here, the last one. So we're going to say Y-intercept equal to 10. So we can draw rough sketch here. But let's try to find turning point. How do you get turning point? Let me explain to you how you get turning point, right? So we know, okay, let me write here. X-intercept, okay, let me move my calculator to the right. Move my calculator here. Okay, so you don't want to come in. Okay, so we say, well, our X-intercept, no X-intercept, but a y-intercept equal to 10. So there's something also, we say any graph, it must have a turning point, especially parabola, where the graph turn. So we have a formula for turning point equal to negative b over 2a. You memorize that, negative b over 2a. Oh, the easy thing, if you want to memorize the turning point, look, my apologies, sorry. If you want to memorize the turning point, remember, you can simply go to your formula. Let me come to the formula here. Go to your formula and take this. This is the x at turning point. That's the x at turning point. You say x at turning point equal to negative b over 2a. That's how you get x at turning point. Very easy. So let's go back here. I'm going to say, okay, well, x at turning point equal to negative b over 2a. You can see, okay, and then equal negative b. What's the value of b? We know the value of b, this one, negative 6. Negative 6 over 2 times a. What's the value of a equal to 1. So negative and negative is going to be positive. 6 divided by 2 times 1 equal to 2. 6 divided by 2 equal to 3. So x at turning point equal to, okay, let me move up a little bit. Hope you can see negative. Because you did not see very clear then, I apologize. Like that. I can repeat that if you want, because you did not see very clear. Okay, let me say it again here, because it was hidden a little bit. Okay, so we say the formula of the turning point, and I'm sorry about that. Turning point formula, negative b over 2a. So say negative x at tp equal to negative, what is a b? B, this number, negative 6 over 2 times a equal to 1. So now negative and negative is going to give us positive. So positive 6 divided by 2 equal to 3. So x at turning point equal to 3. But once you get x at turning point, don't forget, right? Our x-intercept, no x-intercept, and y-intercept equal to 3, which was that one. Okay. So once you get the x at turning point, now how to get a y at turning point? So you're going to say, take the original formula, which you have, say y, but now it's going to be y at turning point. 1 is just a 1. In a position of x, place this x at turning point. So place 3, because you place 3. Minus, 6. In a position of x, place the x at turning point. For now is 3, for this case, plus 10. So you're going to say 3 minus 6 times 3 equal to 18. So 3 minus 18 equal to negative 15, plus 10 equal to negative 5. Oh, okay. So negative what? Negative 5. So y at turning point equal to negative 5. Negative 5. So our turning point is x 3 and y equal to negative 5. So now we have all the information. We want to sketch the graph now. Let me write all my information, and then we're going to sketch the graph quick. So I'm going to say, well, we say no x-intercept, y-intercept equal to 10. Turning point, because any point must have x and y. What is x at turning point? 3. And y at turning point equal to negative 5. So now we can use those information in sketch our graph. And before we sketch, we know how that graph is going to concave. That graph is going to concave upward. Means it's going to open what? Upward, because our value of a is greater than 0. Because like we say, when the value of a is greater than 0, then the graph is going to open what? Upward. Or it's going to concave upward. So I already have a rough idea, because see, this value of a is greater than 0, because 1 is bigger than 0. So we know it's going to concave upward. Okay, let's come and draw. This is x and this is y. Now let's sketch now. So turning point is 3, negative 5. Look, this is like 1, 2, 3, 4, 5, 6, 7. Okay, y equal to negative 5. Let's say this is negative 1, negative 2, negative 3, negative 5, negative 5. Because you know down is negative, up is positive for y. And the, oh, what am I saying here? This is x, my apology, and this is y. This is y, this is x. Y is vertical, x is horizontal. So now we say, okay, value of x equal to 3. What's 3? 1, 2, 3. Value of y equal to negative 5 means negative 1, negative 2, negative 3, negative 5. So where do they meet up? 3 and negative 5 is here. Because x equal to 3, y equal to negative 5. That's a turning point. What is x-intercept? The value of x-intercept? No, the graph is not going to cut at x. What is the y at turning point? Y at turning point is 10. It's going to be somewhere here. But then it's going to be wrong because something I made it wrong. There's no way this graph is going to turn here without cutting the x. So I think at turning point I made a mistake. Or X-intercept I made a mistake. Let me check turning point again. So we say our turning point. I wanted to check my turning point. Negative b. What the b? B equal to negative 6 over 2 times a. A equal to 1. This and this is going to be 6 over 2, which is going to be equal to 3. X at turning point equal to 3. It's true. Now let's plug again to see if what I did is correct, right? Because maybe I made a mistake when I was plugging in. Okay, so we say y at turning point. I cannot repeat what I did here for turning point because it don't make sense what I did here. Y at turning point equal to 1 is 1. What the value of x at turning point? X equal to 3, and then we say square minus 6 times x equal to 3 plus 10. So now 3 square equal to 9. I made a mistake. It's 3 square equal to 9 minus 3 times 6 equal to 18 plus 10. And this is going to give us 1 because 9 minus 18 equal to negative 80 plus 10 equal to 1. So y at turning point, I was wrong. It's just a positive 1, and I apologize. So with this means you also learn my process of me make mistake and correct my mistake. So I was wrong. So the value of x equal to 3. 1, 2, 3. The value of y equal to 1 means 1 somewhere here. X equal to 3 and y equal to 1. And we say our y-intercept equal to 10. Let's assume this is 10 because this is positive here. So if I had to draw this rough sketch for effects, I know it's going to concave upward. I mean, this graph is going to go like this. Because this is a turning point where the graph turned, and then it's going to cut at y. But it did not cut at x because there is no x-intercept. Okay, there's no x-intercept. Let me do another question here. Oh, there's a question which is very, very interesting. Where the question is? Okay, let's do this question right here. Okay, so now they say don't worry about anything for now. Let's just solve it. Okay, so I'm gonna take this question, put up there. Let me just come here and just plug up here. Okay, let me move my calculator to the right. And I apologize only now to realize my calculator was hiding something. Let me check something first. If what I was solving it was visible. Okay, perfect. So my calculator is aside, and I sincerely apologize for that. Now we come here now. We say, okay, let me just come here again. Just a second, just a minute. I'll be back now. Okay, I'm getting the page here. So now if you had to come and pick the graph, we know that graph is going to be for this one here. Because x at turning point it was 3 and y at turning point it was 1, which is like 3 and 1. So for the second equation, is the option number I or 1, you can call 1. The second equation which I took is for this one. So second is this one. Now, let's go to the next question here. Yes, let's take the first one, for example. So the first one also, I'm going to use the formula. So I'm going to show you, okay, let me take the third one. Let me show you now how to use a calculator now. You don't have to, if you have a calculator, don't waste a lot of time doing this. So let me solve the last one. Let me use the calculator solving the last one. So I'm going to put my calculator right here. Let me put my calculator. And they say, wow, I'm going to come here, get the X-intercept. I can come and plug in the calculator. So plug in the calculator, say mod. and then go to equation. So look at your calculator. For me, my calculator, okay, let me say it again. Maybe you're not here. So if you want to use a calculator, you don't have to, if your equation is multiple choice, for example, you don't have to write a lot unless it's written. So if multiple choice, just go to mod, and then for me, equation is number 3. But for your calculator, the equation could be number 2. But all you need to pick after you click mod and then pick the equation. For me, it's number 3. But for you, it could be number 2. And then after that, oh, I clicked the wrong one. Sorry. Mod, press mod, and then equation number 5. Equation is number 5. I'm sorry, number 5. For me, it's number 5, but it depends on your calculator. So press where you say equation. And then which one look like a quadratic there is number 3. So you have to look at your calculator which one look like quadratic, because quadratic have a square, which is number 2. So for is number 3, which has a power 2, power 2. So for me, it's number 3. So press that, and then insert or place the value of A, B, and C. What the value of A? The value of A is a half. So you can simply say 0.5, or you can say half. Or you can say half if you want. No, just say 0.5, because a half, you know, 0.5. 0.5. Did I press 0 here? 0.5. And then say equal. And then when you go to B, B is 9.2. Negative 9.2. Don't forget negative 9.2, because there's a negative. So I'm going to say negative 4.5, because 9.2 is 4.5. You can plug in a calculator, see. And then I go for the last one, 7 1 over 8. So take a calculator, put in decimal, 7 1 over 8. I can say, okay, take my calculator, 7 shift 7 1 over 8, or you can change to decimal. And this is 7125. So that's 7.125. So then say equal. So when you say equal, and then so you have already placed all the value. You can see A 0.5, B negative 4.5, and C equal to 7.18, which is 7.125. So then, when all your values placed in the calculator, just say equal. So when you press equal, that's the value of X-intercept, the face one. But I put in the decimal. So you say 9 plus 2 square root of 6 over 2. So you can place SD. When you place SD, it's going to be 6.949. So it's like almost 7. Or you can say 6.9. So 6.94, whatever, is almost 7. On your approximate my problem. So I'm going to say, well, my X-intercept equal to 6.94, but on your approximate equal to 7. So then I'm going to say, then again, press again equal. And then press SD 2.05, 2.05. So 2.05 is almost like a 2. Okay? So then we're going to say 2.05. It's going to be X equal to 2.05. So that's another X-intercept. So the X-intercept we have. But what is Y-intercept? Y-intercept is this one here. So Y-intercept equal to 7.18. But a 7.18 is like 7.125. Okay? 7.8 is like 7.125. So I can simply say this equal to 7.125. That's a Y-intercept. So we have an X-intercept, which are 2. Why you always get 2 X-intercept? Because X-intercept is where the graph cut at X, and we get 2 value because the value of the highest degree is 2. That's why we have to get 2 value. So now we can go ahead and find the turning point. So turning point, we know the formula. Turning point, let me write here. X at turning point, negative B over 2A. Negative, what is B? B equal to negative 9 over 2, which is negative 4.5. Over 2. A. Was A equal to half? I have 0.5. So you can plug in the calculator there and see what you're going to get. So I'm going to say, well, come into the calculator. And come into the calculator. I want to make sure everything is visible. Okay, and then I'm going to say, okay, so we have to place it in the calculator. First and foremost, I have to clear my calculator. Let me show you face. Because if you say 0, look, it does not want to go away. It's still there. If you say clear, it doesn't. So all you have to clear your calculator. To clear a calculator, there's 2 methods. The first method, you can simply say mod and then press number 1. Now let's see. Fraction. Yes, you see it's cleared already. That's the first method to clear calculator. If your calculator acting funny. Or if you don't want to use that, you can just simply say, look, another way, say shift CLR. CLR means clear. And then number 3, click number 3 means all. And just say equal. And then press AC means all. So then let's go and press here, say fraction. And then we say negative B. What is B? Our B equal negative 9/2. Negative 9/2 is negative, it means negative 4.5. So I'm going to say negative 4.5. Bracket close, bracket close. Oh, I'm sorry, I forgot to close my bracket. Close the bracket, go to the bottom, and then 2A. I mean, this is going to be 2 times A. What the value of A? A equal to a half. A half means 0.5. Close the bracket, close the bracket. So then after that, just say equal. Sorry. So when you press equal, this is going to give you 9.2. 9.2 means 4.5. Let me see if I plug my calculator code. Negative is negative. B. What is a B? B negative 4.5. Yes. 2 times A equals 0.5. Yes, correct. So you say equal means 9.2. 9.2, plug in the calculator. You say SD. When you press SD, it's like you change it to the decimal. Means 4.5. So X at turning point is 4.5. X at turning point equal to 4.5. We want to get Y at turning point. Y at turning point. So before I go to Y at turning point, you say it like this. Look, Y at turning point equal to, you place the value of X's, means these X-intercept right here, you place this X with those value of 4.5. And then you say equal. So we know the value of X at turning point is 4.5, and then you plug in here and in there, and it's going to give Y at turning point. So we're going to say, come here, and they say, okay, a half is 0.5, meaning 0.5, bracket, and then X, what the value of X? 4.5. Bracket, and then after, you must minus 4.5, bracket, what? Bracket X, the value of X at turning point also is 4.5. Close the bracket, and then you plus 7, 1/8, but 7/1/8 meaning 7.125. You can simply change that one to decimal. And then after that, just say equal. So this is going to give you -3. So Y at turning point equal to -3. So Y at turning point, so Y at TP equal to -3. So we have all the values. So X at turning point equal to 4.5 and Y at turning point equal to -3. So I can simply say my turning point 4.5 and -3. My turning point is 4.5 and Y at turning point equal to -3. So these data are enough for me to draw to sketch my graph. Let me write all my data up there so I can sketch my graph. What is X-intercept? X-intercept. Oh, okay, these are X-intercepts right here, and this is the Y-intercept. So we can sketch our graph. Now let me go to the next page and sketch my graph. Now, so this is gonna be our page. So we're gonna draw one by one. Okay. So first and foremost, how my graph is gonna concave. If the value of A is greater than 0, then it's gonna open upward, the concave upward. But if the value of X is less than 0, then we know it's gonna concave what? Downward. Now let's see. Before we draw, we know it's gonna concave what? Upward, because the value of A, which is a half, is bigger than 0. So before we draw, we know the graph is gonna be concave like this. See what I'm saying? We know it's gonna concave like that. Now let's go. Now I'm plugging a value. So well, I can draw little sketches. Okay, well, I think I can draw here also. What is the X-intercept? The X-intercept is 2 and 0.5. 2 and 0.5. Okay, well, let me just say. Okay, let me do this. X equal to 2 and 6.94. Excuse me. 2.05 is somewhere here, let's say. X-intercept, because this is X-axis. And another X is 6.94. It's almost 7. So let's say here is 7. Just do. This is just like a rough sketch. This is 2.05. And this is 7. So then, what is our turning point? Our turning point is 4.5 and -3. if this is 2.05 and this is 7, what is 4.5? 4.5 value of x is somewhere here, let's say rough sketch. And y equal to -3. Y equal to -3 means here, let's say -3. So where do they meet up? 4.5 and -3. 4.5x is here. -3 is here, means they meet up somewhere here. So that's going to be our turning point. So we know for effects this graph is going to go like this rough sketch. X-intercept, turning point, it turn all the way. What is Y-intercept? Y-intercept is 7, 1, 2, 5. Means Y-intercept means going 1, 2, 3, 4, 7. Let's say we assume it's here. Let's say a rough sketch. And this graph is going to go all the way. That's how you draw the graph. So this graph right now, it has the X-intercept. You can use a formula or you can use a calculator. I'll say if you have a calculator like mine or similar, use a calculator because it's going to give you accurate answers. It's not going to waste a lot of your time. And if you can come here now, you say, well, which graph is there? This one here. You can see 2 and 6, almost 6.9. And you see turn here, turn at 4.5 and -3. You can see this is a turning point. So this is going to be for the third equation. Number 2 is for third equation. Number 1, it was for okay. This graph I got from the third equation, which is this one. 3 is for number 2. Apologize. Oh, sorry, I'm sorry, my phone. I apologize. Well, so let's finish up. Let's go for the other one. You see? So the third equation is for this one here. 2. Now let's go for the last one. So this is for people who are beginners. But I'm going to redo this question with a fast pace, okay? So now we go for the first one. So this was for the second one. Second one is for the first. Third one for the second. Now we go for the last one. For the last equation, which question I didn't solve? I did not solve this one here. Now let's go for this one here. So let me just erase all this stuff here. Since I'm done, either use a formula or use a calculator. But I'll say use a calculator because calculator is going to save a lot of your time. So first and foremost, I want to get X-intercept. How am I going to get X-intercept? Take your calculator and then come here, clear your calculator, and that's your key calculator. Okay, now just go to mod and then equation, which is equation. Equation is number 5 for me. Equation. But you can check in your calculator. Okay, quadratic. Which is quadratic? Quadratic for me is number 3. But you can look at your calculator. Which one does it show? Quadratic is the one with the highest degree is 2. You see, this has the highest degree of 2. So I'm going to say, well, let me take number 3 because that's quadratic for me. Now we go. What the value of A? A equal to 1. Because there's no number here. So it's 1. Do you have a 1 with X? Okay, so this I may say X squared. We don't have X, so it's going to be 0x. Because there's no number with the X. And then minus 1, minus 3 and half. So now we know the value of A. What the value of A? Value of A equal to 1 and then say equal. And the value of B equal to 0, just say 0 and then say equal. The value of C equal to negative 3.5. Negative 3.5 is like negative 3.5. So I'm going to say negative 3.5. Negative 3.5. And say equal. So we already have place. You must check here all value of place. And it's correct. 1 is 0, negative 3.5. And then after that, just press equal. And when you press equal, it's going to give you square root of 14 over 2. And then press SC. So, which is 1.87. It's like 1.9. It's approximately 1.9. So our first X-intercept, 1.9. X-intercept. Remember, these are intercept. Okay, now let's go for the second one. For the second one, we're going to say, well, just press equal again. When you press equal again, it's going to be the same value, but on a negative. Oh, I pressed twice. I'm sorry. So just say equal again, because you should not say minimum value, maximum value. No. Just press there. That's what the first one, right? And then press again. See? And then just press SD. You got what I'm saying? So negative 1.87 is like negative 1.9. Look, if you press twice, it's take you to the minimum value and maximum value. You don't need that. So it's negative 1.9. That's my answer. So it's like another value x-intercept negative 1.9. I have my x-intercept. What is the y-intercept? Y-intercept is the last number, which is this one here. So y-intercept is negative 3.5. So you can say y-intercept negative 3.5, which is like negative 3.5. So say y-intercept negative 3.5 is like negative 3.5. That's a y-intercept. So then after that, we want to get turning point, x at turning point and y at turning point. X at turning point and y at turning point. So how are we going to get x at turning point and y at turning point? I'm sorry. To get x at turning point and y at turning point, we know x at turning point is negative b over 2a. X turning point equal to negative b over 2a. Negative, what the value of b? B is, there's no b means it was plus 0x, remember, right? So b equal to 0, because b is plus 0x minus 3.5. You understand what I'm saying? Or let me write again. It's like y x squared plus 0x. I introduce 0 because there's no b there. Minus what? 3.5. So then we're going to say, well, let's plug it in. So it's going to become what? Negative b equal to 0 over 2 times a equal to 1. So we're going to say times 1. So 0, negative times 0 is negative 0. It's just a 0. 0 does not have a negative. 2 times 1 equal to 2. And this is going to be 0. So x at turning point equal to 0. X at turning point equal to 0. Well, so I'm going to say my x at turning point equal to 0. So x at TP equal to 0. What about y at TP? To get y at TP, what we're going to do, take the value of x at TP, and then we can substitute in original equation. It means we're going to substitute here the value of x in the position of, the value of x at turning point in the position of x, and then that's going to give me what? It's like saying, in the position of x here, I'm going to put x of turning point. What is x at turning point? 0 for now. Because this one here, we got x at turning point 0. And then minus 3.5. 0 minus 3.5 is like negative 3.5. It's like negative 3.5. So y at turning point is negative 3.5. So for that being said, now we know our both turning point. X at turning point 0, y at turning point negative 3.5. Okay, so we know our turning point. 0 and turning point is 0 and negative 3.5. So we can sketch our graph. If you can look careful now, we can sketch it way easy. Okay, let's draw the sketch here, rough sketch. What is the x-intercept? X-intercept is 1.9 for positive and negative 1.9 for negative. Those are x-intercept, means where it's going to cut at x. What the value of x-intercept? 1.9. Let's say this is 1. Let's say this 2 is going to be, let's say 1.9 somewhere here. Rough sketch. What is y-intercept? Negative 1.9 means this is negative 1. Negative 2 means negative 1.9 somewhere here. What is our turning point? Our turning point is 0. When x equal to 0, y equal to negative 3.5. Okay, means when x equal to 0 is here, y equal to negative 3 means negative 1. This is a y-axis. Negative 1, negative 3.5 means this 3, somewhere here 3.5. Because this is going to be negative 1, negative 2, because this is a y-axis. X is at 0, means you don't go right, you don't go right. You don't go right, you don't go left. And then at y, you go negative 3.5, negative 1, 3.5 somewhere here. Where is going to turning point? So if you have to draw a rough sketch, we're going to say, well, the thing is going to be like that. Like this. And if you can look careful, this is going to be for the face graph, which is this one right here, the one they give. So the face equation was for this graph here. So if you can look carefully, look. 1.9, this is like 1.9. 1.9, 1.9. And 3.5. Where the graph turns. See what I'm saying? Yes. So, and you can see 3.5, and the same thing with the y-intercept. Y-intercept is at 3.5, and y where turn. This is y-intercept means where it cut at y, and also the same point is turning point because the graph turned there and the graph cut or intercept at y. Let me see if I can do some more question. Oh, but now I can stop here. I don't want to make a very long video, but for that be said, thanks a lot for your time. And if you have any question, please leave a comments below. Share this video to a lot of people, and do please check the link below where we have a program and projects for the community, feeding the homeless, helping the kids whose parents either pass away, orphans, or kids whose parents or guardian who are on drugs, or the under influence of heavy alcohol or drugs. So the kids also they take and being indoctrinated to believe that the only way out is to commit crimes and drugs. So I kind of take those kids and enroll them in a formal education so they can change their life and the loved ones and people in their community as well. See, because we're trying to make some changes. Thanks a lot for time. So you can click the link below and then you can see what we do, all of that. Thanks a lot for time, and I'm gonna see you soon.